Okay, class. So just want to go over some problem for the simple quiz for pre-calc chapter 2. And then the whole chapter is all about transformations, quadratic, finding vertex, and finding maximum, minimums, and also compositions, inverses. So here's some of the following problem that you'll be dealing for the simple quiz. Okay, so we'll look at that. So let's start it off with transformation. So anytime I deal with the transformation, it's always consider y equals a times x minus h quantity squared plus k. So the quadratic one. So again, a is just a scale factor. And h comma k, it's always the vertex. So the vertex sometimes could be the max or could be the min. So let's say if that's going this way, that means h comma k, which is the max. And then if that's facing upward, that means h comma k, and that would be the min. Another way that you can sketch the graph without using the vertex form is by using the standard form. Standard form of the quadratic functions, so ax squared plus bx plus c. So the way to find out the vertex, negative b over 2a, okay? And also that's considered a line of symmetry. So now let's do one problem like this. Okay, so for the first one, again, this one is a simple problem for the test. So let's say we do have y equals negative x quantity times the quantity of x minus 1. Well, you might be wondering, this one is neither the vertex form or the standard form. So in order to get back to the standard form, we need to distribute. So negative x times x, negative x squared, negative x times negative 1, so then that would be positive x. So now, compare and contrast. So this one it's written in the standard form. So let's find out the value a, b, and c. Well, c is not given, so that means c is always considered 0. So now we can find a vertex by using the vertex formula. So it's negative 1 over 2 times negative 1. So then that'll be 1/2. Okay? And then in order to find out the y value, so we just plug in a number back to the original equation. So y equals negative 1/2 times negative, positive 1/2 minus 1. So negative 1/2, 1/2 minus 1, negative 1/2. So negative 1/2 times negative 1/2, 1/4. So we just found the vertex, which is considered 1/2, comma, 1/4. So 1/2, so here's 1, 1/2 is right between 0 and 1. 1/4, it's a little bit up higher. And other thing that we notice, we can find a y-intercept, the y-intercept which is 0. Again, the vertex, it's not just showing you the vertex, but also shows the line of symmetry. So the line of symmetry for this one is going through the x-axis, the x value. And this one is the equidistant, so that means that another point, it's reflected over the line of symmetry. So for those 3 dots, simply just connect. So it's upside down, parabola. Another thing that you might be considered doing is the domain and the range. So the domain for this one, there's no restrictions for the x value, so that means the domain pretty much is all real number. So it's negative infinity to infinity. And then the range, it's all the way from negative infinity to the max. So negative infinity all the way to 1/4. Okay. So that's one of those type of problem. And now, the next one is going to be quadratic again, but this time you need to find a 0. The way to find a 0, that means just like finding the x-intercept or finding the roots. Okay, so we'll look at that in a minute. So the vertex, we just did that, and now it's the x-intercept. So let's say that we have a standard form. or the one that's given with like a random form of the equation. Okay, so something like this. Well, you might be wondering, that's kind of complicated. Well, because we do have a quadratic trinomial on both sides. So in order to find the zeros, we need to bring everything all together to one side. So negative 2x squared, negative 4x squared, so that means we want to add 4x squared both sides. And then at the same time, subtract 16x. And also add 2 constant. So combine this together, so we do have 2x squared minus 4x plus 14. And then everything got canceled on the right hand side. So we do have 0. And now, for the one that might be wondering, can we factor this trinomial by using the double cross or the smiley face? Again, anytime that you want to factor, you want to take out the greatest common factor if that's involved. So 2, negative 4, 14, and they're all considered even numbers, so that means we can take out 2. And now let's find out things that's remaining. Divided by 2 for each term. Even the right hand side. So we got x squared minus 2x, and then plus 7. Again, the 2 doesn't really make any factor here, so we can get rid of the 2. Or just put in the trinomial. Again, identifying the value a, b, and c. Well, the reason why we want to find out a, b, and c because the trinomial is a prime, which is non-factorable. If that's non-factorable, we can complete the square. We can use the quadratic formula for this. So let's find out the value a, b, and c. So a is 1, b is negative 2, and c is 7. So for the quadratic formula, we do have negative b plus minus square root b squared minus 4ac all over 2a. And then the rest of this, just plug in a number. So negative 2, so it's positive 2, plus minus b squared, negative 2 quantity squared, minus 4 times a, 1, and then times 7, and it's all over 2 times 1. And then the rest of this, you just want to evaluate by using the rule of pandas. Parentheses, exponent, multiplication, division, addition, and subtractions. So negative 2 quantity squared, so we do have 4. 4 times 1 times 7, so we got 28, so it's minus 28. And then over 2. And for those you might be wondering, the radicand is going to be considered a negative number. It is. So that's a negative number, so that means there's no real solution. But we still need to find out the imaginary solution. So we do have 2 plus minus, so 4 minus 28, so we do have negative 24 all over 2. So try to simplify that a little bit more, so we got 2 plus minus, and then root negative 24 can be written as 4 times 6i. Again, root negative 1, that's considered I. So I, we can just put it outside. So root 4, which is 2. So we do have 2 plus minus 2 root 6i over 2. And then reduce by 2, top and bottom. So we do have 1 plus minus root 6i. And those are the imaginary solutions. Again, there's no real zeros, but we can find out the imaginary solutions. Okay, so another type of functions that's going to be on the test is like the composition functions. So we'll take a look at that in a minute. So composition is like fog, goth, f of g of x, g of f of x. Okay. So here's another one. So fog of x, goth of x. So fog of x, that is written as f of g of x. Again, g of x, which is the inner function. And then f of x, which is the outer function. Okay. And then for golf of x, so that one is written as g of f of x. Okay, so for this one, inner function would be f of x. And then outer functions, g of x. So now, here's one of the problem. So let's say f of x, so that's 16x minus 20. And then for g of x, it's negative 2x squared plus 6x minus 3. So now you want to find out f of g of x. Well, first thing that you want to do, you always want to start with the inner functions. So the inner function for this one, which is g of x. So it's written as f of negative 2x squared plus 6x minus 3. Now, got to be careful with this. If there's no sign right in between, it doesn't mean that you have to multiply. It's just a composition, so you want to put in one function into another function. So for f of x, instead of using x here, we're going to replace this whole quantity. We're going to replace that x with this whole quantity. So it's going to be written as 16 times the quantity of negative 2x squared plus 6x minus 3. And then minus 20. And then the rest of this, all you need to do is just simplify the whole thing. And then combine the like terms. So 16 times negative 2x squared, negative 32x squared. 16 times 6x. So that one is going to be 96x. 16 times 3 minus 48 minus 20. And then combine the like terms. So we got negative 32x squared plus 96x. 48, negative 48 minus 20. So that turns out to be negative 68. So eventually it's going to be a quadratic trinomial. Okay, so that's one of the sample problem. So now let's see what else that we have. So with transformation, we also have quadratic and the absolute value. So make sure that you guys need to follow through that, the template, the one that we did in class. Just follow through those forms, the transformational form. Another thing that you need to know is about finding the domain of a function. So anytime they want to get a domain for the functions, the one that we have to do without graphing it is by finding the restriction. So normally once we deal with linear, quadratic, there's no restrictions for the domain. If there's no restriction for the domain, that means it's always all real numbers. Or it could be going from negative infinity to positive infinity. Okay, so let's say that we have a line graph. Okay, so see that here? There's no restrictions for the domain. So pretty much once you set up the xy table, you can use any number, any real number for the x value. So that means the domain for this one is always negative infinity to infinity. And then same thing happened with the quadratic. It's like parabola. Again, you can use any number for the xy table, any real number for the x column. So that means the domain is always negative infinity to positive infinity. But now, what happens once you deal with a function that's considered rational, or is considered rational with radical? So now we'll do one example from each time. So let's say that we do have something like negative 18x minus 4 times x outside, all over, negative 16x plus 4, and then negative 4x plus 3. So first thing that you want to check, so what kind of expression, well, it's a function. So what kind of function this is? Well, this one obviously is a rational. So the way to find out the restriction is by the denominator, by looking at the denominator. So once again, going back to third grade math. So anytime any number divided by 0, it's always considered undefined. So the way to find out the restriction is simply set the denominator equal to 0. Well, this one is already factored, so just set that to denominator equal to 0. So by separating this negative 16x plus 4 equals 0, and then negative 4x plus 3 equals 0, so we can find the restriction. So negative 16x, so that equals negative 4. So that means x equals 4 over 16. It's negative over negative, it's positive, reduce. So 1/4. So that's one of the restricted value. And the other restricted value, so that would be for this equation here. So negative 4x, it's equal to negative 3. So that means x is what? 3 over 4. So compare and contrast, so 1/4 obviously is less than 3/4. So the way to find a domain, so we always go from negative infinity to infinity. So starting from negative infinity, it's not included because we don't know how small that is. And it goes all the way to 1/4. And then union that means and, or with. And then it's 1/4 to 3/4. And then union again, 3/4 to infinity. So we do have 3 different intervals for the domain. So negative infinity to 1/4, 1/4 to 3/4, and then 3/4 to infinity. Okay, so that's one of the examples for the rational function, finding the domain. Now what happens once you deal with things that is like combination? Combination for rational and radical. And that was something we did in class. That was what, 2.1? Finding the domain for the complicated function. Okay, so we'll look at that. So let's say that we have something like this. So it's a function combined with linear and rational. Well, the first part of the function here, that's linear. And the second part of the function here, that's considered rational with radical. So now for the linear, there's no restrictions. So that one is always from negative infinity to infinity. But the problem is right here. So the whole thing here is not just considered rational, but also the denominator, it's a radical. So back to the parent graph for the radical. So y equals square root of x. Now, as you can see that here, so x, the quantity, the radicand, it's always greater than or equal to 0. But now, here's the thing. So the whole quantity here is under the denominator. So that means the radicand, it must be greater than 0. Well, it cannot be 0 because that it will be undefined. Another thing is that because the restriction for the parent graph of a radical function. So solve for x. So that means x is greater than 1. And then rewrite it with the domain. So this one, it goes all the way from 1 to infinity. Okay? Well, the reason why that is because this part of the domain here is negative infinity to infinity. So we want to find out the intersections of these two domains. So things that they share in common is from 1 to infinity. Okay? So again, negative infinity to infinity intersect with 1 to infinity. Then that be from 1 to infinity. Okay, so now let's see what else that we have for the rest of this. Another thing that I would like to show you is about the making a graph for the piecewise function. So a lot of people still having a hard time with making the piecewise function. Again, piecewise function, it shows the restrictions with the domain. Okay, so we'll look at one of those. So let's say that you want to sketch the graph. Of f of x and f of x that involve with the linear part and the quadratic part. Okay, so this one is for x is less than negative 2, and the other part is that for x is greater than or equal to negative 2. So as you can see that anything that's from negative infinity to negative 2, we're using the first function, which is quadratic. And then anything that's greater than or equal to negative 2, we're using the linear. So let's start with that x-axis, y-axis. So negative 2 is right over here. Okay, so that's quadratic, so that means this one is going to be like a parabola. Okay? So normally the parent graph is just like a parabola with up one to the top. Okay, so it's going to be a parabola here. Now, but the thing is that this one is being cut off. So this one is only restricted for things that it's less than -2. So anything that's less than -2, that means it's going to be like this. The reason why that I put in the open circle, because that open circle is not included. The point, it's not included. And now, anything that x is greater than or equal to -2. So for this line right here, x plus 5, so just sketch the graph normally. So the y-intercept is 5. So 1, 2, 3, 4, 5 up here. And then the slope of the line can be up 1, 1 over to the right, or it could be down 1, 1 over to the left. Okay? Down 1, 1 over to the left. So eventually it's going to be like this. Okay? So you're probably wondering there's a gap right between. Well, sometimes they're not connected because that's a piecewise function. So it shows the one that's from the left-hand side for anything x is less than -2. And then for the linear, anything that for x is greater than or equal to -2. Okay? And then the last thing I need to show you for this one, it's about the inverse function. So the way to find out the inverse functions, so a couple of things I need to watch out. So that's just a set of numbers, so all you have to do is just swap the xy value. But what happens if that's given with f of x? So that equals 2x squared plus 3x. So we're going to find the inverse functions of f of x. So first thing that you want to do, you want to rewrite that f of x as y. So y equals 2x squared plus 3x. And then the next step, you want to switch the xy variable. So x equals 2y squared plus 3y. And now from here, you want to solve for y in terms of x. Well, this one would be a little bit difficult, so this one you need to complete the square for that. So let me change that to another example, something that's easier. So quadratic, so that's a little bit hectic because you need to complete the square. But now let's do the one with just like linear. So let's say we do have x plus 3 over 2. And then you want to find the inverse. Again, first step, just rewrite it. Y equals x plus 3 over 2. And then you swap the variable. So we got x equals y plus 3 over 2. So after you switch the variable, you guess what? You want to solve for y in terms of x. So here's another thing that I can do. If there's nothing down beneath that variable, so that means it's always 1. It's a fraction. So that we can perform cross multiplication. So 1 times the quantity of y plus 3, then that would be y plus 3. And that equals 2 times x. So that means y equals 2x minus 3. So now we just solve for y in terms of x. Another thing that we have to do, the last thing. So simply just rewrite that y as inverse of f of x. So inverse of f of x, that equals 2x minus 3. That would be the inverse functions of f of x. Okay, so again, anytime that getting stuck with something, so always you can rewind or you can fast forward the video. So just watch any kind of content, especially the one that you struggle. Okay, so thank you for watching the video today.